This is the screencast for section 3.8, example 3. The derivative of the arcsecant is, yes, another formula you're going to have to memorize, and of course memorizing it is going to become a lot easier once you understand the proof here. But there's an additional concept that's kind of catchy on this one. We have a plus or minus sign because of the Pythagorean identity that we use within this proof, and then we have the ability to get rid of that plus or minus sign by using an absolute value here. So take a few minutes, look through this proof, and then understand why the derivative of the inverse secant of u is 1 over the absolute value of u times the square root of u squared minus 1 times du dx. In example 3, we're going to use the formula. So at this point I'm going to assume you have it memorized. And it's asking us to find the derivative of the inverse secant of 5x to the fourth. So in this case our u is 5x to the fourth. So the derivative of that will be, 1 over, the absolute value of u, so the absolute value of 5x to the fourth, and then times the square root of u squared, so 5x to the fourth squared minus 1, times the derivative of u. So the derivative of 5x to the fourth is 20x to the third. And then to simplify a little bit, I'll put the 20x to the third in the numerator. And in the denominator, 5x to the fourth, because x to the fourth, that's an even exponent, that will always be positive. I don't need the absolute value anymore. Underneath the square root, I have 25x to the eighth minus 1. And then to simplify even further, the 20 and 5 reduce, and then x cubed over x fourth gives me 4 over x square root 25x to the eighth minus 1. Now try problem number 17. Asks us to find the derivative of y, which is the inverse secant of 1 over t. So in this case, our u is t to the negative 1. So the derivative of y will be 1 over the absolute value of t to the negative 1 times the square root of t to the negative 1 squared minus 1, and then times the derivative of t to the negative 1, which is negative t to the negative 2. So now I've got a t squared that can drop down to the denominator and a negative 1 in the numerator. So this is going to look rather complicated, and we can leave it in exponent form, or this is another reasonable form of the answer.